This video is an overview of the requirements and specifications for SUBBASE and base course aggregates. The videos after will explore the specification testing in more detail. The SUBBASE and base course and most flexible roads are unbound aggregate layers. Aggregate is a mix of separate gravel and sand particles. Unbound means the aggregate particles are not cemented or otherwise stuck together. Unbound aggregate or granular layers rely on the interlocking of the various aggregate particles for their strength. The separate aggregate particles and the mix of the aggregate particles need to have a number of properties to enable the aggregate layer to support and distribute the road loadings. Roads need to provide a smooth, safe running surface for decades with minimal maintenance, so the aggregate layer and the particles that make up the aggregate layer need to maintain their properties over long periods of time. So the properties of both the whole mix and the individual particles is important. Important properties of the whole aggregate mix are its grading, which is the mix of the different particle sizes of the aggregate, and the strength of the compacted aggregate layer, which is often measured by the California bearing ratio, or CBR. The coarse materials in the aggregate mix need to be angular, be able to withstand the loads of them without crushing, and be able to withstand erosion by weather forces such as rain, running water, and wind. The finer proportion of the aggregate mix cannot have too much silt or clay. The proportion of these materials, the silt or clay, is measured by sand equivalent and plasticity index tests, among others. Granular layers and the materials used in them need to be tested to demonstrate compliance with these requirements. The required testing and acceptable results are set out in specifications. One of the most useful sets of specifications related to roading are produced by the New Zealand Transport Agency, NZTA, formerly known as Transit New Zealand. A link to the NZTA publication site is in the resources section. The New Zealand Transportation Agency are responsible for designing, constructing and maintaining all state highways in New Zealand. To do this, they have developed a series of specifications that cover all of the works and materials involved in roading. In this video, we will look at the NZTA specifications which apply to state highways, but which most councils also use. You'll recall that councils are responsible for the roads that aren't covered by NZTA. However, it should be noted that some councils have different requirements for their roads, but these are usually pretty close to the NZTA specifications. However, NZTA has no specification for sub-base materials, although there is a set of notes providing guidance on the requirements for them. These notes are titled TNZ-M3, Notes on Sub-Base Aggregate Specification, TNZ-M3. This document sets out what a sub-base specification should include and the minimum requirements that should be set out in it. However, it does not provide the details required to define the sub-base properties. It is left up to local councils to define the sub-base specifications for their area. This is done because the types of rock that can be used to produce sub-base vary considerably around New Zealand, and one specification would not allow the flexibility required to enable local materials to be used. The requirements suggested in the notes are similar to those used in the NZTA base course specification, M4, which we will look at now. NZTA produces a specification for base course materials, which has been adopted by most roading authorities in New Zealand. This specification is called TNZ-M4 Specification for Base Course Aggregate. There is also a set of notes providing clarification and elaboration of the requirements set out in M4. Copies of these documents are included in the topic page. Section 1 of TNZ-M4 is one sentence setting out the scope of the specification. You can see it in the slide here. So it sets out the scope of the specification, which is to provide the requirements for base course aggregate. Most specifications start this way with a statement setting out what they cover, that is their scope. Section 2 of the base course specification is general requirements The main one being that all sampling and testing is done by an IANZ accredited laboratory. This means that the laboratory has the equipment and skills required to undertake the testing as required by the specification. IANZ are the government organisation tasked with making sure that testing is done properly. These tests need to be carried out using specific procedures, most of which are set out in NZS 4407-2015, Methods of Sampling and Testing Road Aggregate. This document provides a detailed description of the steps required to carry out each test, so everyone does the test in exactly the same way. This allows the test results from different labs to be compared. This means that the results of testing on specific materials provide an accurate indication of its properties and allow designers and road controlling authorities to set out specific requirements based on these tests and have confidence that the road will perform as anticipated. NZS 4407 is produced by Standards New Zealand, who are a government organisation dedicated to providing standards for industry. They produce hundreds of standards ranging from detailed descriptions of requirements for steel bolts through to standard contract agreements to be used in engineering contracts. Standards significantly reduce the amount of work required to practice engineering and ensure what we produce will do what it is supposed to, and that there is consistency across the industry. They are identified by the NZS or AS/NZS prefix. The AS/NZS are standards jointly shared between New Zealand and Australia. It costs money to purchase these standards, but you don't need this standard for this course. However, if you can get a hold of one, it's worth having a look, although the tests that are set out there are really only of interest if you are working in a lab. For this course, you just need to understand what the tests are done for and what is acceptable results, all of which is set out in the specification. Section 3 specifies the requirements of the source material. The source material is the rock from which the aggregate is produced, and the tests required by this section determine the property of the rock material itself. Rock aggregate is produced in a quarry, which quarries the rock, crushes it, screens it into sizes, and then mixes the aggregate into the required mix of coarse and fine particles. This photo shows an overseas quarry. You can see the quarry face in the background, where the rock is removed from. In the foreground is a machine which crushes the rock and sorts it according to different sizes by screening. The different sizes are then mixed to form the base course aggregate. The aggregate particles need to be made of hard source material free of soft or other materials that would prevent the aggregate from supporting the road loadings without breaking up or being crushed. The material also needs to be able to maintain this hardness even after decades of exposure to the elements. Therefore, the tests in this section relate to the crushing resistance and strength of the materials, as well as how well it resists weathering. This section also sets out the amount of testing required. For example, if the rock has been quarried changes, then a new test needs to be done. However, if there are no change in the rock, then tests need to be taken on one sample for every 10,000 cubic meters of rock quarried. Section 4 of TNZM4 sets out the requirements in regard to the production properties of the aggregate, that is, the quality of the aggregate mix itself. The main test is the grading of the aggregate, that is, the proportion of the different sizes of sands and gravels that make up the aggregate. Another set of tests relate to the clays and other fine materials in the mix. There will be some fine materials in the mix, but too much can reduce the strength of the final base course by trapping water in the voids between the aggregate particles and lubricating their contact points. You will recall that a base course relies on the contact areas between particles to transfer and distribute the road loads, and anything that reduces the effectiveness of these contacts will result in the base course layer not being as strong as it should be. The specification requires that aggregate particles be broken or crushed, as we need angular aggregate particles to maximize the contact area between aggregate particles. Rounded particles will have small contact areas, resulting in the load being concentrated and an increased risk of the particles crushing, as shown in the diagram here to the right. Therefore, the specification requires aggregate particles to have angular faces, as shown in the example to the left of the diagram. This section also sets out the requirements for sampling. Aggregate is usually sorted into lots of similar material. It is inaccurate to test just one sample, so the specification requires a number of samples to be taken and tested from each lot. The number of samples required depends on the amount of base course that has been produced in that lot, ranging from 2 samples for a 400 cubic meter lot to 4 samples for 4,000 cubic meters, and an additional sample for each 1,000 cubic meters after that. So you would have to undertake the full range of tests on 6 samples if you had a lot of 6,000 cubic meters of aggregate. The last half of TNZM4 addresses variations in properties of base course from different regions in New Zealand. The requirements of TNZM4 are changed in some areas to allow local rock to be used, and this section provides amended specifications for different areas. It also addresses the use of melter slag and recycled crushed concrete as base course aggregate. You do not need to review this half of the specification, although it may be of interest if you're involved in roading in these areas or if you are using alternative materials. In the following videos, we'll look at source material and production property tests in a bit more detail.